We all remember the great photos of crew members Kjell Lindgren and Scott Kelly as they ate lettuce on the station. And then Scott Kelly showed off his green thumb by showing us beautiful pictures of the zinnias he had grown in space. Well, all that is thanks to a facility called Veggie. I spoke with Joya Massa, the veggie scientist at Kennedy Space Center, to get the latest on the lettuce and find out what astronauts will be growing next.
Yeah, I don't think any of us expected that. We think it's exciting, but we really had no idea how the general public would respond. And I mean, we've had media inquiries from all over the world. Many students have been really engaged by it, which has been wonderful. The general public. I think it came down to the people that like growing plants, the people that like to cook, and the people that like to eat. And that's a lot of people. So
pretty much everybody.
Yeah. It was a huge success. We learned a lot, and we were just delighted that the astronauts were able to eat the lettuce finally. So.
Did it taste like lettuce?
Well, from what we heard, it tasted fresh. It tasted a little like arugula. Some of the plants in this group get some more bitter compounds if they're under some stress, and they were under some water stress. And arugula tends to be a little more bitter than lettuce. So when we heard Scott Kelly said,
kind of like arugula,
we thought, that's really interesting. Maybe it did get some of those more bitter compounds, but I think in space having that enhanced flavor is actually really desirable. So they seem to really enjoy it. There wasn't a lot. They didn't get to eat a ton.
And not a full salad.
No, and we are still bringing back some frozen for scientific analysis to just confirm. So we didn't let them eat all of it, but they
you want to
seem
eat
to
some
like
too,
it.
right?
Yeah, but probably not frozen.
Hi, Scott Kelly aboard the International Space Station. I want to go and check on my flowers I'm growing here in the Columbus module.
So after the lettuce, they were able to grow the zinnia seeds that we had on orbit. And so we'd sent zinnias. We weren't sure when they would be able to eat the lettuce, so we wanted to send a crop that they wouldn't want to eat, but that they could enjoy and have bloom. And zinnia is a great model system for longer duration crops like tomato. And so this is a really great test for the system to see how it runs under a longer duration. And also, zinnia is a flowering crop. And so tomatoes will have to flower before they set fruit. So seeing how crops flower in the system, seeing if there are any limitations on that is really important.
It's kind of nice to have some flowers up here when you don't see much that is alive and growing besides the 6 of us here.
It's had a psychological effect too, and I think that's what your hopes were as well, right?
Yeah, I mean, we're very interested to see this, and we also have future, experiments where we'll actually be evaluating some of that. But just seeing the crew enjoyment, seeing them take the flowers out, move them to different parts of the habitat. They posed with one of the first flowers for the 300-day photo, and then they put it on their dining table for dinner that night.
Aww.
So I think it really shows the impact of having something green and growing when you're living in this environment so far away from Earth and from green growing things generally.
So what's next? What are we going to see next growing?
So next we're sending some Chinese cabbage and some more of the red romaine lettuce. The Chinese cabbage was actually selected through a human research program funded study where we down selected crops based on how well they grow, their nutritional attributes, looking specifically at nutrients that are really desired for the space diet, and their organoleptic attributes, how the flavor is, how well they taste. We actually grew produce of a bunch of different varieties, sent them to Johnson Space Center from Kennedy, where they did the taste evaluations at Johnson. And this Chinese cabbage wasn't the most nutritious, but it was by far the best horticulturally. It was a very productive, fast-growing plant, and it got off the charts organoleptic evaluations. People just love the taste of it. So we think that the astronauts are going to love this as well. We are going to send more of the red romaine lettuce also, and those 2 crops will be sent up on SpaceX 8. We're also going to try sending some ranch dressing in the future to go along with their salad.
Okay.
Yeah.
So they're going to need some tomatoes for that salad, though. When are we going to see that?
So over the next couple of years, we're working on growing tomatoes in this system. We've down selected also a small variety of tomatoes. It's about this tall. It's called Red Robin, and it's a cherry tomato. And so we will have our next couple of veggie flights. We're going to actually be doing experiments, and this is something that I'm leading a team from Kennedy, Johnson, Purdue University, and Orbitech, Orbital Technologies Corporation, that developed the veggie. And we're doing light recipes for these crops. So we're going to see what is the best red to blue ratio to give the best nutrition and flavor and growth of the crops. And we're also going to do some fertilizer testing. So we'll do this with Chinese cabbage again, and then we're going to do this with dwarf tomato. And the Chinese cabbage will be probably around the end of 2017, and the dwarf tomato will be around 2018 timeframe. We're going to actually have 2 veggie units up there by that point to be able to do some side-by-side testing.
What did you think when you saw the Martian and he was growing his own food?
Oh, I thought that was wonderful. I think it really raised awareness among, the general public and NASA as a whole about the importance of food production and, getting us to the point where we will be able to grow a larger percentage of our diet. And also just the importance of having plants, in a scenario when you're on this really desolate, environment like Mars or even, a space habitat.